Hello everyone, welcome to Salt Analysis Lecture 3. And in this lecture, we will be covering the Group 2 anions. Basically, Group 2 anions are the anions which, upon testing, they don't give a gaseous product as the interference. So, we have to put them in a separate group. And, well, say you are testing. Wait, I forgot to give the intro. So in this in this series, I will be giving you theory plus memory hacks, and we will be covering salt analysis in a very concise manner for JEE mains or NEET. Oh, I forgot to write it in the thumbnail. One second. For JEE main or NEET. I sorry, I'm feeling very funny today. Yeah. So salt analysis, theory plus memory hacks. Give me one chance and I will fix your salt analysis. We will be covering sulfate and phosphate ion, and this is the group 2 anion. So say you have done all of these tests that we covered in earlier lectures and all of those tests have failed. Now what? Then you have to test for group 2 anions. Now, do you really need a trick to remember two anions? Like this is sulfate and phosphate. If you really need a trick to remember these two anions, then I have to say your memory is so poor. Here's the trick. So sulfate per phosphate. Now, one special thing about these anions is that you have to do a direct confirmatory test for these, and they are segregated because they don't give gaseous products. You will see when we go to that tests. And the best part, there is no preliminary test. So this is the easiest category we are doing so far, and all you have to do, you have to memorize three tests. And even for those tests, I will give you tricks. So let's not waste any further time and let's go to the sulfate ion. I have written the sulfate ion formula wrong. Forgive me. So this is SO42 minus. And basically, what is the test for the sulfate ion? Let's do it quickly. All you have to do, you have to take the sodium extract of the salt. You have to react it with acetic acid and barium chloride, which will give you a white PPT of barium sulfate. And it will be insoluble in HNO3 and concentrated HCl. And the second test is nearly the identical one. You have to see what's common here. You have to take sodium extract. You have to take acetic acid. You have to take BaCl2, and here you have to take PbAc2. Uh, Basically, AC we call the CH3COO group. Okay, so it's very similar, and both of them give white PPTs, and both of them give similar PPTs. This is BaSO4, this is PbSO4. So those are the two tests for the sulfate ion, and that is all. Let's read the theory of the lab manual. Aqueous solution or sodium carbonate extract of the salt acidified with acetic acid. I have written it like this. On addition of barium chloride gives white precipitate of barium sulfate insoluble in concentrated mineral acids. And the reaction is so easy, and even that you don't have to remember for mains. And the second one is nearly identical. You have to just react this and it forms lead sulfate white precipitate. That's it. And even for this, I've given you a memory hack, which is this pebble sure is white. Like you are walking on the beach and you come across a pebble. This is a rock. When you pick up that rock, you see that it is very white in color. So using this, you can remember both of these tests. This pebble sure is white. White is of course a reference to both the tests giving white PPTs. And pebble is literally just P is for PB and B is for barium. Pebble. Sure is white, and SU of sure is for sulfate. That's it. That was the entire sulfate ion. Now, you should not have trouble remembering this, considering that we have done so much difficult tests earlier. and this is rather easy. So even I am not doing that many efforts to make you memorize this because I know you can do this. You can do this. I'm proud of you. So before we move on to the phosphate ion, let's learn about an element. Let's learn about molybdenum. Molybdenum is the 42nd element of the periodic table. It is a metal. It is a transition metal, in fact. D block. Its atomic weight is 96. Like, these are trivial facts. What actually matters here is that it shows a positive 6 state. And one of its most famous compounds, which we will be using in this lecture, is that this ion. This ion basically, you can call this the molybdate ion, and that's it. Now you are fit to learn about the phosphate ion test. Let's learn the theory of this test. Concentrated HNO3 and ammonium molybdate solution to the test containing phosphate ions and boil. Yellow coloration in solution can be let's not do this. There's too much yapping. And see, as the PDF writer has mentioned, there are multiple PYQs asked from this paragraph, but I'm going to explain it to you. So all you have to do, you have to take the extract of the salt containing the phosphate ion. You have to react it with concentrated HNO3 and ammonium molybdate. Ammonium molybdate. What is the formula for ammonium molybdate? This is ammonium molybdate. Like here you can see, this is MOO4, and like here you have to remember that the oxygen is in -2, molybdenum is in, what is the oxidation state of molybdenum? It is +6. This is -8 in totality. So this ion gives -2, which is counterbalanced by 2 ammonia moles with +2 oxidation state. So this salt, when we react it with concentrated nitric acid along with our salt, our extract containing the phosphate ion, we get a canary yellow precipitate. Canary yellow is basically the same color which has been used to highlight. This is canary yellow. And this, you have, salt analysis is like a dictionary. So you have to use this dictionary to remember the analysis. So canary yellow. Canary yellow automatically means ammonium phosphomolybdate. Now you will have trouble remembering this formula. I know. You don't have to remember the reaction, but you have to remember this formula and also this formula. So this formula is rather easy. You can just remember it like this is mu, molybdenum, ammonium, mu. You can remember it like this. Now, of course, this sounds silly, but this is a memory aid again. And if we talk about the canary yellow precipitate, well, there's a point mentioned in the lab manual as well. Each oxygen of phosphate has been replaced by MO3O10 group. Now, if you look at the MO3O10 group and you look at oxygen, oxygen also has a -2 oxidation state, and the MO3O10 group also has a -2 oxidation state. So it disappeared. Well, whatever. So this has the capability to replace oxygen in any phosphate ion, and it can replace it with the same stoichiometry because both of them have the same oxidation number. So here all that happens is that PO4 3 minus, you have the phosphate ion, the O gets replaced by MO3O10 4 3 minus, and this -3 charge is counterbalanced by 3 moles of ammonium ion, and that's it. Your canary yellow precipitate is ready. So that was it. That was the entire test in 3 slides. And this slide is also unnecessary. I just made it so I can tell you molybdenum shows a +68. And that's it. Sulfate and phosphate are done. They are dead. And even for them, there's a trick to remember. Group 2 anions. This pebble shot is white. I will take it to Phoenix Mall. Now basically you were walking on the beach. You saw a pebble which is white in color, and you were so amused by the color of this pebble, you wanted to take this to a mall. And that mall was called the Phoenix Mall. Now, how do I use this to remember the group 2 anions? Well, this exact line was used for the sulfate ion. So first line is for sulfate. P say you have to remember Pb. From B you have to remember barium. From Su you have to remember sulfate ion itself, SO4 2 minus. And white you have to remember the white PPT. And using the second line, Phoenix mol is basically just pH. It is just phosphate ion. And using mol, you have to remember, like similar syllable is there, you have to remember molybdenum. That's it. And this is a rather short lecture, but the anions were short as well, so who's complaining? And tomorrow we will begin the basic radicals part. And let's do a quick recap. If you have to test for the sulfate ion, there is no preliminary test. All you have to do, you have to take your sodium extract, you have to bathe it in acetic acid and barium chloride solution, which will give you a white precipitate, which will be insoluble in concentrated HNO3 or concentrated HCl. And if you have the sodium extract of the salt, if you bathe it in acetic acid again along with lead acetate, it will give you a white precipitate of lead sulfate. That is it. That's it, the sulfate ion. And for the phosphate ion, you have to react it with concentrated nitric acid with ammonium molybdate, and you have to boil it, which will give you canary yellow PPT. Oh, and there was also another memory aid here. Phoenix, in theory, it is a bird which is on fire. Okay, it's a bird which is on fire. This looks like a terrible bird, but this fire basically this is yellow, and using this you can remember the canary yellow PPT. Okay, so what was the phosphate ion test again? You have to react the extract with concentrated nitric acid with ammonium molybdate, and you have to boil it, which will form a compound which is called ammonium phosphomolybdate. What will ammonium phosphomolybdate look like? You have to replace all the moles of oxygen in the phosphate ion with the MO3O10 group, which holds the same oxidation number as the oxide ion. Okay, and once this is done, this entire thing will have -3 charge, which will be counterbalanced by the +3 charge coming from the ammonium ions. Ammonium ions here are the spectator ions, and they don't take part in the reaction. Okay, this gives canary yellow PPT, and that was it. Group 2 anions is done. Notes I will upload after we have completed salt analysis completely. Okay, and keep revising. Like, I have taught you salt analysis from scratch, but if you want to keep everything that I have taught you in mind till now, you have to keep revising. Once I give you the notes, you can take a printout of those. Maximum it will take like 14th of January. It's 10th January today. And by 14th of January, you will have these notes on your device, and you can take printout of those. And if you cannot wait up till that point, whenever I speak using a slide, I am giving you time to take a screenshot of that slide, and you can print out by your own. Okay, and make your own notes that's favorable in comparison to taking my slides. So that's it. Let's meet in the next lecture, and thank you for watching.